Hello, Lafayette Lions. This is Miss Taylor. Our new unit is about force, motion, and energy. Well, the world around us is in motion. Motion is movement. Things are in motion all around us all the time. Objects need energy to move. This energy is called a force. Without a force, nothing would move. So the wind is a force, right? It moves things. So let's look at this photograph. Here's some dogs, and behind them is a sled that is attached to them, and a person is moving with the dogs, right? The dogs are providing a force through their energy to create movement in the sled. What kind of motion is this? Is this a push or a pull? How can you tell? If you said a pull, you are correct. Very good. Forces between objects can cause a change in motion, like when we play basketball. So again, a force is a push or a pull. There's other forces as well. Work is the use of force to get something done or to move something. Push is a force that moves an object away, while a pull is a force that moves something toward or with you. Effort is something that is produced by work. Let's check out some more about forces. Pushes and pulls can cause objects to move, stop moving, change speed, right, to go faster or slower, or even change direction. Gravity is a pulling force. It brings an object toward the earth. So when you're playing basketball, we're pushing to try to shoot a basket while gravity is pulling on our basketball, trying to pull it down. So there's lots of forces that can act at the same time on the same object. Try this to play around with forces like gravity. Find two small objects, one that is lighter like a piece of paper, the other that is heavier like a fork. Drop them from the same height. What do you think will happen? Will one touch the ground first? Let's think about sports for a minute. It's really cool to think about force, motion, and energy with sports. What sports do you like to play? Think about all the movement in sports. What kind of forces are happening? During our unit, we're also going to learn about simple machines like the lever, inclined plane, wedge, wheel and axle, the screw, a pulley, and when we put two or more machines together, the compound machine. Simple machines make work easier to do by increasing or changing the direction of a force, and we have many uses for them. Speaking of simple machines and force, motions, energy, I have a question for you. How do you lift a lion? Since we are the Lafayette Lions after all. How do you lift a lion? This book is by Robert E. Wells. And it's going to show us how simple machines help make work easier as we think about force, motion, and energy. Did you ever try to lift a lion? You'd have to be awfully strong. It's because of the force of gravity. Gravity pulls objects downward. When that object is as massive as a lion, it pulls pretty hard. With a lever, you can lift a heavy weight with much less effort. The main part of a lever is a bar or rod which balances or pivots on a fulcrum. If the force side is longer than the load side, you will have leverage. Leverage adds force to your own strength. With a force side this long, you could lift a lion. Now, do you suppose you could lift 10 lions? The longer the force side is compared to the load side, the more leverage you will have. So if you had a lever with a handle this long, maybe you could lift them a little. Look at this lever. There's the load side, the fulcrum, that's the part that moves, and the force side. Did you ever try to pull a panda on a pallet? It would be pretty hard. Gravity, remember that force, is pulling down on that panda. And there's also friction between the ground and the pallet. Friction or resistance happens when two surfaces rub together. The more weight pushing on the surfaces, the more friction there is, and the harder it is to move something. If you put wheels on your pallet, there would be less friction and you wouldn't have to pull quite so hard. Wagon wheels are mounted on axles. At the wheel's center is a bearing which turns on the axle. A bearing's inside surface is smooth, so it makes very little friction. Oiling a bearing's inside surface makes it slippery, so it has even less friction. This is called lubrication. Wheels with bearings make much less friction than pallet bottoms. That's why you can pull the panda now, even though he's just as heavy. It's pretty cool. That wheel and axle sure made it easier to move or pull that panda, do that work. If you begin to go downhill, gravity takes over to pull your load. Gravity not only pulls objects straight down, it pulls them down slopes. So now that you don't have to pull, you could carry a much bigger load. I like how they've hopped onto that wagon. Pull of gravity, direction of object being pulled by gravity. Oh, they're going down a hill. Now, you could carry a pyramid of pandas, and the steeper the slope, the faster gravity will make you go. If the slope began to get very steep, you'd probably wish you had more friction to slow you down. Turn your head sideways. Did you ever try to deliver a big basket of bananas to a baboon birthday party? It would be mighty heavy. Oh, if only there was a simple machine that could help us lift something. Ah, there is. With pulleys, it would be much easier to lift. A pulley has a wheel with a groove around it to hold a rope. When you lift with one pulley, your lifting strength stays the same, but the direction of force is changed. So she's pulling down to lift up. With two pulleys, your lifting strength is doubled. You'll use twice as much rope, but you can also lift twice the load. Yes, pulleys make it much easier to deliver a big basket of bananas to a baboon birthday party. But perhaps a smaller basket would have been better. Oh, I want to go to that party. Our world is full of simple machines. The levers, wheels, and pulleys in this book are shown in just one of their many forms. Each of these simple machines comes in many sizes and shapes and can be used for many purposes. Yes, there are levers, wheels, and pulleys almost everywhere you look. In your house, in your classroom, in your community, all over the place. Did you know that when you row a boat, the oars are actually levers? Likewise, a screwdriver is a lever when you use it to pry the lid off a paint can. And when you cut a piece of paper, your scissors are two levers working together. What would our lives be like without wheels? You'll find little ones on your skateboard, bigger ones on your bicycle, huge heavy ones on a train engine, and tiny ones inside some watches. There are other forms of wheels you might not even recognize, like the doorknob you turn to open your door, or the faucet that turns off your water. Pulleys pull you up in elevators and ski lifts. They help raise sails on sailboats and flags up flagpoles. With pulleys, a window washer can lift himself or herself right up the side of a skyscraper. Look around your world and you'll discover many more examples of levers, wheels, and pulleys. How many can you identify? Thank you for letting me share one of my favorite stories about work and simple machines with you, the Lafayette Lions, and I'm excited for us to continue learning in this unit. Bye, everyone.